Hi, I'm Bill Hewitt, the Information Systems Manager at Fletcher Jones. For those of you who are home dressmakers or have seen home dressmakers at work, you might wonder why we'd need sophisticated technology at FJ's. Well, like many companies today, we need to rely upon technology in order to remain competitive and to ensure that we maintain our famous service. We've attempted to apply computers in many areas throughout the organisation, from the automation of processes and operations on the factory floor, through to monitoring our productivity, and finally gathering data and refining it into information for our key decision makers. But before we start on that, I thought it might be worthwhile if we have a bit of a tour through the organisation, starting at the factory, having a bit of a look at garment design and fabric selection, through the machine room floor, and finally to the important part, the retail outlets. We've come a long way with the introduction of technology at Fletcher Jones, and there's been many milestones on the way. It all started in 1965 with the introduction of punch card equipment to assist in the recording of sales data. By 1972, we introduced our first computer, a small IBM System 3. In 1975, we did the first step into the factory for automation with the introduction of a Gerber 90 and a Markomatic system for design. In 1976, we converted the punch cards to barcodes for sales recording, which gave us a lot more flexibility. In 1977, we did the design work for our production monitoring system, REACT. In 1978, we introduced made-to-measure onto our Markomatic system to enable us to process individual orders. In 1979, we expanded the Gerber cutters with the introduction of a 91 and introduced a laser cutter for cutting made-to-order suits. In 1980, we completed the design work for our raw materials purchasing and inventory control system. In 1981, we introduced point-of-sale terminals throughout the retail chain. Now in 1982, we've developed a 5-year plan stretching into the future. Perhaps now we could look in more detail in 4 general areas where we employ computers. Firstly, in the area of creative design. Next, factory floor automation. Then, productivity monitoring. And finally, where we condense data into information for our key decision makers. To assist us with our graphical activities, we use 2 Markomatic systems, each using 5 interlinked Hewlett-Packard mini-computers, video displays, etc. For each style, the pattern pieces are entered into the system using a digitizer. We only enter the standard or sample size and let the Markomatic system grade the many sizes we support. In some products we support over 100 sizes. The patterns are finally plotted on a large flatbed plotter as both the sample size and as a nest of sizes. This enables our designers to approve the shapes and size grades the computer system uses. The pattern design subsystem is also available to us. This enables the designer to modify existing styles interactively using a video display, streamlining the development of new styles significantly. To produce a production marker, we define the required styles, the sizes needed, usually 6 or 8, the fabric width, and any specific fabric constraints such as nap, one-way, etc. A marker maker can then construct a marker working interactively on the system to minimise fabric waste. The system stores the constructed markers on a disk for later transfer via magnetic tape to our computer-controlled cutters. In addition to some very sophisticated electronically controlled sewing machines, we have 3 computer-controlled cutters. We are still using the Gerber System 90, originally installed in 1975. The System 90 is, however, limited to very low cutting heights. Its maximum is 3/4 of an inch and is now operating on a single cutting table, which is supported by a cantilever laying up table using air flotation, which we developed to compensate for a potential factory layout problem. Our main stock cutter is the Gerber System 91, which runs on 2 cutting tables. This enables the laying up and picking off operation to be fully overlapped by cutting. Loading each of the cutting tables, we have Bulmer automatic laying up machines. They construct layers of the required length and height, which are then floated, using techniques developed by our own R&D engineers, onto the bristled cutting tables. Both Gerber cutters are driven by Hewlett-Packard mini-computers, supported by additional electronics to precisely control the movements of the cutting head. The cutting head on the Gerber 91 is actually 4 machine tools in one. A drill, which is used to mark matching points, etc. for the assistants in the machining room, an annotation pen to number bundles for picking off, knife sharpening stones, and the knife itself. The controlling of the blade movements is very complex, involving speed, direction, and angle of incidence. A separate analog computer is continually sensing the lateral pressure on the knife and making minute angle adjustments to compensate for the pressure variations involved with worsted fabrics. As you can see, the Gerber 91 is a long way from the Eastman cutter, our original automatic knife introduced in 1946. It is even further, though, from the computer-controlled knife technology used in the Gerbers to our latest cutter. The correct length of cloth is fed into this cutter on an aluminium pallet, and the computer controls the focusing of the laser. It's literally done with mirrors. We can cut a suit in less than 3 minutes with this machine. The output are the pieces needed, size adapted for a specific customer. In addition to the cutters, we have used microcomputers to assist in the dispatch function, and our raw material goods receipt and warehousing is fully controlled by a modern distributed computer system. We talk of garments being constructed in so many minutes, but it actually takes more than 10 days to manufacture a pair of trousers. That is, to move the garment through all the operations involved, from cutting through to pressing and final inspection. Each operation on our garment has been engineered to minimise the time needed. The calculated standard time duration for each operation is known as the SAM, or Standard Allowed Minute. During the day, our machinists keep track of the number of garments that pass through their operation. At the end of the day, they summarise these counts onto their bonus sheets. Our REACT data entry operators collect the bonus sheets each evening and enter them into the REACT system. The system extends the operation count by SAM and determines the productivity of individual machinists, calculating bonus to be paid, etc., section and complete factories. The history retained within the REACT computer system enables us to compare each section's performance against our plans and to optimise our production lines. We have 3 computer systems involved in the classic functions of data processing, such applications as inventory control, accounting, payroll, personnel and retail audit. For these tasks we use an IBM System 3 Model 15D, a Hewlett-Packard System 3000 Model 44. The System 3 and the System 3000 are based in Warrnambool, and the System 34, which controls our point-of-sale terminal network, is based in Melbourne, but directly linked over communication lines to Warrnambool. The object of these systems is to gather data efficiently, to condense the gathered data into usable information, and finally to communicate the needed information to our key decision makers throughout the organisation. Well, I hope you enjoyed seeing what we've achieved to date. In the future there will be more developments in a broad range of areas, so there will be a lot more milestones for us all to pass, and we're all looking forward to it.